All right, I am back. Welcome everyone. Let's switch to the main screen. Oh, that chat is a little bit small. Good morning, Mr. Halsey. Good morning, Bear. And hi, 82. Hope you're having a wonderful day so far. It is... So, just for those of you who are watching maybe the VOD for this, to get the appropriate level of, I don't know, horror shock, it is September 8th, and it is currently snowing outside. It was 90 degrees this last weekend, and now it's snowing outside. Oh, the weather of Colorado. Let's make this bigger. Yes, but I live in the colder Rado, except when it's the hotter Rado. Like, that happens too. All right. Enough of that craziness. Now we can work on programming and ignore the fact that frozen ice is falling at a decent pace outside. I mean, maybe this will put out some of the fires. We have at least 2 fires in the state that have basically we're told they will never be contained until like the winter comes. In the mid-Atlantic, it will be so warm, hot through to October, then a mostly mild winter. Yeah, I guess I was expecting the same thing to happen here because it was getting really hot for a while. But Colorado being Colorado, it's saying like, you know, we like to be different. We like to make you set the heater to turn on in the summer sometimes. So your pipes don't freeze. Okay, so where did we leave off yesterday? Yesterday was a longer stream because it was Labor Day. And we got a bunch of stuff done. But we are running into a performance issue. And I have a couple ways that we can fix it, plus one way that we can just ignore it. Let's go into streamer. So for those of you who have not seen this, here's the game. I play as the player down here, and you all play as the chatter. So you get to drop things by typing #fire space and then the column number, and that will drop this fire, for example. I eventually will be adding in more things, so you can drop more items, and they'll be doing different things as they drop them, so it'll be harder for me to avoid. But the idea is that I have this much time to live, and you have that much time to get me. It's sort of like you could work together to trap me or anything else. And so if we drop a fire, that will come down. It stays around for about 5 seconds, and then it disappears. And the hitching we're getting is every second we're updating our timer, and that's a problem. Oh, we're gonna have to. I thought we filtered that out. I guess we didn't do any filtering. Thought we did though. Oh, because the streamer and me are different things. Yeah, the idea is that I don't usually try to attack myself. All right, so one of the ideas for helping out with that is in our interface, we're drawing the time left. Now it's happening every single second, not on the between times. So I would almost think that like the between times would have problems too, because this action where we're creating the text and we're doing all these set bounds and everything else, that's pretty expensive. Now if I just draw you, I think you're gonna put it, say don't do the bounds. let's say I just put it into point 2 new, just somewhere, I don't know, we'll drop into the middle of the screen for right now, like 250. I mean, I have the screen width and the screen height. I can put it in the correct spot. So let's say like 0, let's see, this is gonna be screen width minus whatever the width of our text is, but we can just guess and just do, 200.0 pixels. And then for our Y, let's just go down like 5. So if I do that, that way I'm not doing all these extra calculations to it. We're just doing the bare minimum. Create the text, display the text. Smooth, very smooth. So the time we can see is like, it's small now. But there's no hitching anymore. So that tells me that this is much more expensive than I was expecting it to be. What we can do is we can move this into two, like a 1-2 punch, as it were. We can store in our struct for this, we can store the time left text, or the time, let's see, time left text can be a text here. And we can have a function that calculates the time left. I guess it wouldn't be calculate time left. It would be, we want to like update time left. Let's just have a function update. I don't think we have a function update here at all. This will yell at me if I try to do another one, right? Let's see, what else do we need? We're gonna need, let's see, font default, that's fine. It's all internal. Sort of the idea of what I want to do. We don't necessarily need to return anything. I want to take these things. I want to move them down into this function. And I'm going to call it during the update loop to create our time left text, and then store that inside of inside of the main struct. That way here in draw, all we have to do is a reference to self.timeleft text. And so here we're going to say self.timeleft text equals time left text. All right, so what do we need? We need obviously the amount of time left. So time left. What are you? You're a U64, right? Yeah. We need screen width and screen height. And I think that's pretty much it. So we're gonna have this, gonna make you public. And then we can call this from outside. And so this is gonna create our time left text. It's going to set it up, and then we're going to assign it. Now in here, we're just gonna do these things. All right. That seems about right. Now there is one problem, as it were. We do need to do this once. to sort of like set the time left. So I'm thinking we could have like one more function that will get and return this, and then we can and it could be the equivalent of like a static method on here. So I can't remember the term that Museum used for it. Let's see. So this is going to be an internal function for create time left text. We're not going to take in self. I think in this case, we're going to take in the time left and the screen width and height. And we're going to return a text. And we're going to do this stuff in here. So then the idea is that self time left text can equal self create time left text. And then we can pass in time left. And in this case, we don't need to take in the tuple, we'll just take in screen size and pass in screen size. And then at the end here, we return time left text. So that makes you happy. When I call you, I don't need to pass in the type. So the reason I want to do this here is because at the top, we need to have our time left text. So now we can do self create time left text, set our initial time left. We can pass that in here. So a new, we have initial time left, because this is really like a game decision. So we can say that you are a U64, I believe, is what we decided this was. Yeah, U64. Okay, so you come down like that. We also have the screen width and the screen height here, so that's perfect. All right, so initial time left comes in there, and the screen width and screen height come in there. All right, so that gives us the time left in there, and so now we need to call those two functions. So when we create the new interface, we're now missing this initial time left. So let's see. Game time, we have that right there. All right, so that gives us our interface properly. What are you? You are game time. Oh, you're a duration. We can just set you to be that as sex, which turns it into a U64. And then in our update function, we'll call that update. So here's this new calculation for game time left. If it's 0, we stop. Otherwise, we recalculate what the game time left is. So in this case, we probably don't need to store this. We can now just pass it in to be drawn, because every frame we're having to recalculate this. All right, so otherwise, we'll do self dot interface dot update, pass it the game time left, and we have the screen size somewhere. Oh, do we not? Is that not something we've had to calculate? Oh no, here, your screen size right here. Let's go ahead and move this all the way up. Right there. Since that's where we need to use it, everything is technically working. Let's see how this runs. Still that hitching. Oh, and it's not drawing properly. But it's probably creating all those text. So that's it's too expensive still. For us to like we update. So we update, which updates our time left text. Our draw for display time left text just draws this out. And so it doesn't really care about this. But my guess is that update is super expensive. So the next thing that I want to do is only do this calculation, only like do the build thing if the time has actually changed. So we can store the time left, which is a U64, and we can use this to essentially cache. So time left, we'll just set you to be the initial time left. Then way down here, in our update, we get to check to see. So we're only gonna do this in the case that our time left changes. So if time left is not equal to self dot time left, then recreate the this text here, and then of course that draws out. So how does this work? I mean, still not working. The creation of those meshes and doing the calculations for like the I mean, it's mostly the meshes because we saw that, right? It's actually setting the font and scaling it up. That seems to be really, really expensive. So we like caching it doesn't seem to work, where we only update it when we need to. Then in that case, we may have to give up on like what we're like. We may have to give up on like having it drawn out like that. We could send a message back to chat. Or we could just not have the timer. Like we'll need a timer anyways to like know if the streamer won. But we don't have to like display the timer inside of the game. Like maybe we should just set that somewhere else. I suppose another thing is like, I wonder if there's, we can't use a thread for this because I don't have context to be able to draw things out. And I need a context in order to create the text. Is that correct? And scale it? No, I don't need the context for it. I mean, that might be like just a little bit overboard of what we need to do, and a little bit crazy. I think potentially a different architecture that allow us to update these in a different way. I don't know. It feels a little bit odd that this is what's causing major time problems, which leads me to believe that I'm actually being too expensive somewhere else, and this is the straw that, you know, broke the camel's back. So I'm thinking for right now we'll just punt, not do the text for it. So we could just not do our updates, not display the timeout. So we'll just remove all of this. Not do any of you. It's a slow morning all over the place? Yeah. Is it also slow in less streamers streaming, or is it just everything is running slowly? I haven't rebooted my computer for this, thinking like maybe like a fresh computer running this will be a little bit faster. But no, it isn't. Okay, so then in here, we don't need to store the time left in game. Seems like people must be playing catch up at work, and not watching streams, at least from like a 3 to 5 channel sample. Oh, you know what? That kind of makes sense if people were on vacation last week because of the, like, I mean, from the Americans' perspective, if people were on vacation last week due to Labor Day, and then they're coming back this week, or they're on vacation this week and, you know, not watching streams. Possible. Very, very possible. Okay, so do I need to store the time left in game? I don't know if I need to. Down here we have... Okay, so here you're upset. We're not going to run update on this, so we don't need you anymore. All we really need to do now is... I deleted far too much there, didn't I? Just you. Okay, so if calculate our game time left, and then if our game time left is 0. And that's really what it is. So we don't need to store this away. Okay. So if I set you as 10 seconds. Will I just win after 10 seconds? It won't display it. But I'll still win, and it's... Yeah, it's nice and smooth during that time. You know, I kind of wonder if I could do the calculation and have like something dropping along the right as the timer. That could be really interesting. Because every second, maybe like the font is too expensive for me, but I could do a mesh that's just like a rectangle and then have the rectangle move off screen, and that looks like a timer coming down. I like that idea. And then all we have to do is calculate how fast to move to determine when we win or not. And so we know that we're working on like 60 frames per second, and we know like what our space is, so we can figure out what the speed is to move it off. So let's actually do that. So this should probably be an interface. No, it's gonna be a game object type thing, but maybe we give it the interface ownership of it. So in our main library here, let's create timer block. So let timer rectangle. All right, so I don't need to create it as a sprite. I'm thinking just like just a rectangle. So we're gonna have no sprite. We will need a draw system for it. We'll need a draw system. So a draw system will need, let's see. We probably don't need to get the size because it's not an image. We'll need a physics system for it. All right, so let's go ahead and add these in. Draw system first. So we have like a single draw system here. We're gonna have to switch this over to like a trait. So we're gonna have update and draw, and this takes time since start. Which then updates the sprite with that. Oh, and that could allow us to update. Okay, so that's not bad for us. Context and location, and that's fine for that too. So let's say I do a trait here. So if I do a trait like draw system, I know you're gonna be upset at me because I have a struct to name that too. And in here we're gonna do a function update. Okay, so you take a duration and you don't return anything. And then we have draw. And you return this. Okay, so if I do that as a draw system like this, then instead of this draw system, you're gonna be like a game object draw system. we're going to end you here. And then we'll do an impl draw system for game object draw system. And then that gives us, okay, we don't need pub here. And then you're happy with that. Oh, you have this get size. Oh, we need get size too. Okay, so that makes you happy. Let's see, so then you're going to be impl game object draw system. And so just to make all of this work, let's go back to the main library. We're going to need both the trait and that. So we're going to have, oh, you need to be public, don't you? We have draw system and game object draw system come out. And then down here, wherever we use this, instead of draw system new, this is going to be, let's actually fix that. Okay. Wherever we have draw system right now, this is going to become game object draw system. But we're also going to need just the draw system trait, because we're now going to store inside of game object for this draw system. Instead of an object option, we're going to have a box dyn draw system, like that. Oh, right. And so then we need to add in debug into this draw system, which we remember we had to do here. So where self standard format debug, we need to just add this in. Okay, so let's fix all these errors now. All right, so an option. So everywhere where we have like this option, now it needs to be a box dyn draw system. Okay, so our draw system, some flame draw system. So we get it from the game object draw system. Right, so we need to box this up now. Okay, no more errors. Everything is working. Let's double check that. Everything is working. It's nice and smooth. We can still drop things. Oh, nope, too late. I'm sure I could drop things. It's fine. Rust is one of those languages where if it compiles, it's like, I mean, generally speaking, it works. I mean, for like almost every time. Almost. There's some times when like underflow or overflow that causes problems. But the vast majority of the time it just works, which is really nice. Okay, so now that we have that, we can create a draw system for that's just like, this is a generic game object draw system. I want now, and so what we would probably want to do is create something like we have physics here. So inside of source, let's create a new folder, and we're going to call this draw. Probably draw system. And then we're going to throw a draw system inside of here. And rename it to mod. And so, okay, it's going to grab it straight from here as like the mod that's coming in from draw system. And then we're going to want the game object draw system. So a new file. Okay, so then game object draw system.rs. And inside of here, so we have our trait. I want to take all of this, cut that away, and put it in here. And it's all public, so that's fine. In our mod, we want to mod game object draw system, and then use that. So pub use game object draw system, game object draw system, and so now that's available to like library, for example. Oh, the drive debug, I missed that. So then you happen out here. Okay, so what are we missing? Sprite, text, we need to add all these in now. And I think pretty much all of these. Let's see, pub use, so we don't need that. Implement, okay, so we do need to, so we have Sprite. We also need to bring in just draw system. And no errors, so that we've successfully like refactored this into like a folder system for the draw system. Which means that I can now create a draw system for our like timer draw system. So we know that we need to bring in that what is it? The draw system trait. Like we know we need to bring in context. So use GGEZ, context, and game result and those type of things. Game result, and graphics. It's going to be a rectangle, which means we're going to need the mesh stuff. So graphics, we need a mesh builder, a rect, a draw mode, and a draw param. I'm not completely sure what else I need right off the top of the bat, but let's go ahead and create this. So pub struct. This is going to be a timer draw system. So if I do that, and then we can re-export this out here. So mod timer draw system. Use timer draw system, timer draw system. Okay, so now that's going to be available to us out in the main library, so we can just work on the rest of this. All right, so what are we gonna need to store? We're gonna need to store the time left, really? I guess like we're gonna have an update for it too. And the update is going to like tell it where it's going to be. It's like it doesn't need to be its location. We just need to draw a rectangle, don't we? So we're just gonna have our like the timer. I don't want to call it like timer. Well, I guess I could. We're gonna have the timer be a mesh. I don't know if we need anything else with this. All right, so for this, let's go ahead and return. Oh, this is gonna be a game result that holds a timer draw system. We're gonna return, okay, let's, I guess, just do this. All right, so let timer equals our mesh builder. Our mesh builder is going to be a rectangle. So our mode, so draw mode, we'll fill this. Then we're gonna have our bounds. That's gonna be a rect new. And then we're gonna have like give it the X, the Y, the width, and the height. So let's start this at like 0, 0. Let's do we want to do the entire screen? Do I want this horizontal or vertical? I could have it horizontal, it's like moving left. I can have it vertical and going down. The vertical might actually be really nice. So we start at 0. I'm going to do this at 0, 0. So it's going to be on like the top left corner and it's going to be going down, and then I can translate into place. So that will be like easier to work with. Because I'll give it like a location and I can just sort of shift it down. But therefore our width can be so const, this is going to be timer width. We'll just say that this is 5 pixels. Timer width. Jeremy Who subscribed with Twitch Prime. Thank you so much, Jeremy Who. Thank you, thank you, thank you. Also, welcome. Awesome to have you here. Let's see. Timer width. Oh, and then our height, we want this to be the entire screen height. So we need to pull in the screen height from this. So let's get screen width, screen height, 32, screen height. So that's the entire height of the screen, and then it will be translating down. And then our color, like what do we want to color this as? Can I create a color here? Oh, that means we need to pull in a color. All right, so if I do a color new, let's make this just like red to begin with. All right, you're happy with that, so perfect. So I can just do this as our timer color. Then we build, we hand it the context that we don't have. Okay, so we need the context too. That returns out of view, and then we need to store this inside and return at the same time. So we're going to return an OK, timer draw system, and store timer. All right, so that gives us a new draw system here, and then we're going to want to implement draw system for this timer. So impl draw system for the timer draw system. I wish that like when I did that, it would automatically pull in the functions for it too. That would be really nice, especially the ones that are like absolutely required. So we know that we have function update. So we're gonna get the time since start, which it's a duration. This might actually help us out. This is, however, a draw system, so I don't actually know if I want to do any of like the updates to that, so I might just ignore you. And we might actually just not do this. We have draw. So pull in context, pull in the location that we have, which is a point 2, which we did not bring in. Okay, so we have this draw here. What do I care? What do I care about this? I want. I guess like for drawing it out, we're just gonna literally draw it out exactly what it is and translate it over to where the location tells us to put it. So we're just gonna do a graphics draw context self.timer drop param and send it to the destination, which is gonna be the location. And that's it, and we just return that. And then there's one last thing that we're not implementing, which is that, we don't implement debug, so we need to fix that. And we did, get size. Which returns as option F32, F32. Well, we do actually have a size. We probably want to then store that in here. So like our width, F32, height, F32. And we actually have the timer width here. If we do that, well, yeah, it'll be fine. So here, do width is timer width, and then height is going to be the screen height. So then in here, we're going to return a sum tuple self.width self.height. All right, so that makes us all happy here. So what does this mean? We can now come back to our main library and use this. In fact, we already have it in the draw system here. So the timer draw system, Oh, in our timer draw system, we have to re-export it. So pub use timer draw system, timer draw system. Oh, I already have that there. We need to publicly export it. So that way here in the main library, we have access to it. There's the timer draw system. And here we go. Create the timer block. So the first thing, we don't have a sprite, but our draw system that we just created here doesn't take in a sprite. It's just does its own thing. So our draw system is first. New, okay, so we need to pass in the screen size, which we have there. So screen size, and then the context, and then question mark semicolon at, and we've got a draw system. Next up, flame size. I don't actually know if we need that. Oh, we need to be able to tell what the size is for the game object. So I guess we do need that. Okay. Oh, and then we can do the unwrap or to give it a nice default here. So we know that you're going to be like 5.0 and screen height. So that way, if anything changes, that's just our default of what you're going to be. You're actually screen size .1. Okay, so now we have a timer size. Then we're going to create the new game object. Oh, we're going to need a physics system for this. Let's actually get it drawn out to screen, and then we'll work with the physics system later. So. Okay, so what do we need here first? It's X, like its location of where it's going to go. We can put this in like just the top left, and we'll see it in the top left of the screen. And I think that'll be fine for right now. And we can translate this later. So y 0.0. The draw option, so you're going to be a sum timer draw system. Our width, right? So we have our size. This is going to be timer size .0. Timer size .1. Our physics system, we don't have one yet. How long we want this to live for? This is a none because it lives forever. Collidable is false. Nothing can collide with it. And then a chatter. And I think this is a none. There's no chatter for this. Nobody's part of this. That gives us a game object. We can now store that game object in the interface. What are you upset about? Mismatch types? Oh, right, you need to be a box. There you go. Now we can store you inside of the interface. So interface dot add game object, timer game object. And that just throws that into its internal vector, and all the updates and draws should just happen to it automatically. So I should be able to run this and see our red line down the left-hand side. There it is. That's not terrible. So I click over here because I saw my mouse on it, OBS, but of course, that's not over here actually. So, I mean, that looks appropriately right. We could move it over here eventually. Let's now make it go down as we're reducing in time. So we need to, let's see, that's gonna be our physics system. And we have, let's see, this is gonna be our timer physics. .rs. All right, so use super physics for, I guess it would be our physics system as our trait. I'm not sure exactly what else we need with this. So pub struct. This is gonna be our timer physics system. And in our mod here, let's do all these things. Okay, so we re-export that. What do we need here? We're gonna need our location as part of the game object, but we do need a velocity that needs to get set. And this is probably, we only need this to be an F32 because we're just gonna be moving downwards, and that's all we really care about. And I could, just to be very explicit, we'll just set this to be like a velocity Y. And then we're gonna set this at the beginning based upon what we know the time is gonna be. So we need to know like the total game time and the screen size. And we also need to know the frames per second, like the target frames per second that we're going for. And then we can just sort of move down based upon those three things should give us the velocity that we really need. So what is that? Where you need the screen size. We're gonna need like the duration of how long the game is gonna take. So I guess this would be like game time. It's gonna be a duration. And we're gonna need, let's see, so we have the height, the duration, oh, and the target frames per second. Which is, I think it's a U64. I don't remember. We'll figure that out. And then we're going to return a new timer physics system. All right. Need to bring in a duration. So how are we going to do this calculation? Given 60 frames per second, given 10 seconds, I want certain number of pixels to move down every single frame. So let's say 10 seconds is our game time. And let's say that we have like 1,000 pixels high that we want to go down. So 10 seconds, I want to go a full 1,000 all the way down. So we hit the 1,000 at the end of the 10 seconds. Is that just going to be the game time divided by the screen height. We need to use the frames per second also to like limit ourselves so we don't go too fast either. How will this math work? Math is like the bane of my existence. No, it's actually like math is the thing that I'm the most weak on when it comes to like these type of things. So it's always fun when I have to do these type of calculations. Okay, so if I just choose some arbitrary number, let's just see how things work out. If we have 1,000 pixels down, and I set, I want to move by 10 pixels. We want 10 seconds. So what do I know that I need to move down by? Let's bring our calculator. So that'd be something like 1,000 divided by 10. That'd be, okay, 100. So that'd be 100 pixels every tick down. That's going to be 100 pixels every second that I want to go. And so then I want to divide that by 60. And I want to go 1.66 every frame. I think that's how it is. So it's going to be the first one divided to get the number of pixels per second. It's like the ratio for the duration, and then divide that result by the FPS to get the per tick. Okay. So let's break this out into its component parts. We're going to do the sort of like the moving down per second. So pixels per second equals, this is going to be, what did we do? We did 1,000 divided by the number of seconds first. So that's going to be our screen height. Now, do I really want this to be like the screen height? I feel like I want to actually make this be something slightly different. I want to just know like the full length, like the timer width. It's like the timer size is going to be an F32. So we're going to have our timer size divided by the game time dot as sex F32. So that gives me pixels per second. Then I want pixels per frame. And that's going to be our pixels per second divided by the FPS. And so you really need to be a U32. So I'll make someone else do the calculation up there. Actually, I need you to be an F32. Then I need to return this as the new timer physics system. So we're going to turn a timer physics system. Our velocity Y is going to be the pixels per frame. And there we go. That's gonna be the entire timer physics system. All right, so we're gonna impl physics system for timer physics system. What are we missing here? We need to implement debug for this. And we need update, and that's it. All right, so we're going to take in location, which is a rectangle a context, game object, and return a result. Let's put a to-do in here to make that result, this return, be happier. Rect, context, and game object. Okay, so that brings all of you out. Now, I want for this... for update, the only thing that we really care about here is having just like, let's increase our location. And then we'll have an okay at the end. Oh, this is an error. So we also need an error. Result, that makes you happy. All right. So the location we want to update you. So location dot, it's just gonna be your, not your height. We want to update your position. So your y. So location.y plus equals to self.velocity y. And that's pretty much it. Everything else we can ignore for right now. So if we do that, come back to our main library, create a new, so create a timer block. Let's create the physics system for this. We need to bring that in. Okay, so the timer size, that's just gonna be the y. So timer size dot one. The game time, so that's actually game time like that. And then the frames per second. So I think we actually have that. Are we storing that? We have this frame rate target here. And here we go. We set the frame rate target there, so we can pass in the frame rate target. All right, so that gives us a new timer physics system, which means here, this will become a sum. You'll need it to be a box, new, timer physics system, like that. This mismatch types found expected F32 found an integer, so we need to convert you. I don't think I can do a dot into. No, I can never do dot into. We'll do an as F32 to cast you into there. All right, so then we're happy with this. And so now let's see if that causes it to then move down. I don't remember if the interface is actually running update on the game objects. I want to say that it's not. In fact, I don't even think we have an update function anymore on the interface. Yeah, that isn't running. So let's go ahead and add that in. So interface. Mute self, and then I don't remember what else we need on top of this to run that update. We're going to loop through all of our game objects, and I think we can do that with a for each loop here, because I don't even think we need a try for each. So we're gonna do a self dot game objects dot turn them into an iterator. A man with a stick. Good morning. This guy is raiding you. I don't have. Well, that looked like a link. I don't see a raid message coming in. So I don't know about that. Let's see, iter. Or otherwise, it's a preparation for somebody raiding me. All right. Let's see, iterator. Okay, so we create this into an iterator, and then we can do a for each. For our for each, we're gonna have our game object. Oh, this needs to be immutable, so this needs to be an iter mute. And then for our game object, we run update on it. Okay, so then here we need all of this stuff. So we need the time since start, the screen size, context, and collidable game objects. So that means we need to pull in context from here. And get the time since start. Const, what the hell? This is not JavaScript. Time since start equals timer time since start. Which means we need to pull that in. Timer. Random link from account opened today. I'm guessing it wasn't genuine. That's probably true. And that's why I have link protection on. Although Bear was suggesting that I get another bot that allows me to whitelist some links, because Twitch doesn't allow me to do that. I just haven't gotten around to do that yet. But that makes sense. But yay for link protection. Also, good morning, Utsby. All right, game object update. Okay, so then we can have our time since start. We pass that in. You are update returns. Oh, update does return a result. So this needs to be a try for each. And then that's fine for that, which means we need to handle you. Game result, like that. So what are you upset about? Expected a game error, found error report. Oh, right, because you're not this, you're a result. Wrong. Right, we need to make you an error result. All right, screen size. Cannot find value screen size in a scope. Okay, so then we need to figure out what the full screen size is. Well, we can go do that here too. Okay, that gives me the screen size. The context is being passed through, and then collidable game objects. What are you? You are a reference to a vector of other objects. I don't really care about that, so I can just create game objects. I can set this to be an empty vector and then pass in a reference to this. Like that. And then you're happy. So let's call update now from the main library. So we should just be able to do this down here. We have to match it because it's that error. And then actually it can't do the other one. So we can do if let error equals self.interface.update, pass it in the context. And so if we have this error here, then we're going to do ePrintline error updating game objects in interface error. There we go, and that should update that and run that function. So let's go ahead and see if now our line goes down. By the correct amount too. So we want this to like be endgame as soon as it reaches the bottom. So no, the answer is the timing. The timing is a little bit off. So our math calculation is wrong. Let's figure this out. So we're off by like one chunk of that, like 1 second, I think. So maybe I need to do like -1, like pixels per second. Let's see, timer size, game time -1.0 first before we do this division. Oh, there we go. Okay, so it was off by 1 for that. Now, if I change the time, which is going to be the main library here, let's say we make it 15 seconds. Then it's a lot slower. I mean, it's not a lot slower, but it is slower. So it's handling like the 15 seconds. So now if I move this over to here, we're going to see the timer right in sort of like this interface area. So, okay, that's perfect. I like that. And then what I want to do is I just want to place that when I create this timer block, the X needs to be positioned over by the timer, by the interface. Let's see, it's going to be the screen size dot 0 minus the interface dot instruction width. And so that should be on the left-hand side of it. There we go, look at that. That's perfect. And it looks like it's pretty easily visible in the stream too. So I like that. And I guess like, is there any last things that I need to do about that? I don't think so off the top of my head. Let's go ahead and update our README. We fixed the bad performance by basically not making it a number. So we're not updating all of that information anymore. Instead, we're using just a completely different visual design to show the time left. But I guess that just goes to show that like there's multiple ways to solve each problem, and text is not the best way. Sometimes we can just do something visual. Okay, so by doing that, let's go ahead and fix all of these warnings we've got. So we don't need any of these. Don't need graphics here. Don't need duration. We no longer need our timer text size. Our initial time left, what is this? This is an interface. Yeah, so we no longer need to store this. Which means we no longer need to pass this in. 1 second, we no longer need 1 second. Oh, that guy is spamming a lot of channels. I wonder if he's trying to get a whole bunch of follows on a channel and then sell it. All right, so we don't need an instant here. Time left is not used. This is on interface, so let's go ahead and remove you. So we don't need time left in game here. Time left in game, so this is in game state. We don't need you anymore. Time left in game, we don't need store you. Okay, so this is in a time physics. I can't like not implement these, but I can underscore them. And that's it. No more errors. So let's go ahead and run this again. And here we go. We can now see the time left properly as I move around. I actually like this a little bit more than the text of it. So I think this is an improvement to the game design. I like it. All right. So let's close all these windows down. We've done all that refactoring that we need to do, and I'm going to go ahead and push this code changes that we've made up. So now we're displaying time left as a bar that drops. And I'll push that up. The repo for this is bang repo. If you're watching Navad, I'm gonna put the link to that in the description. Otherwise, I do have this command here, so you could always run this in the chat window. All right, well with that, I think I'm gonna call it a day because I've gotta go get ready for work, that entire thing. Coming up in future streams, so tomorrow morning, we're going to start working on adding new entities that we can spawn in. So I've been working on tagging and sort of organizing some of those assets that I have in my asset, well, the asset library that I sort of like put together inside of Notion. And we're going to like find one, use it to give options for multiple different things that we can drop down. And then after that will be polished. So I'm doing these specific this game stream. So it's my programming before work. It's like the generic projects that I'm working on. I'm doing those Monday through Thursday, 7 a.m. to around 8:15, 8:30 a.m. Mountain Time. And on Fridays, I'm doing Exploration Fridays. We don't know what we're going to look at until probably like the night before, the morning of. And then Sundays is Tutorial Sundays, where I'm building a Introduction to Rust tutorial course series, name to be determined. Anyways, with that, switch over to the ending screen. And Mr. Halsey is streaming. How many of us are there? Oh, there's 9 of us. Okay, there's plenty of us. Let's go ahead and set up a raid to Mr. Halsey. Do raid channel, Mr. Halsey, start raid. All right, everybody, have a great rest of your day, and I will see you all next time. Bye.